Hello, welcome back. This is part 10. We're into double figures. Get in. Um, in today's episode, I'm going to cover a few things. Um, the main two things that I'm going to talk about are my using the UV resin to fill in all of my portholes on the hull, which now makes the hull genuinely watertight for the first time. And I'm also going to talk through my design of the electronics. The electronics isn't installed into the boat yet, but I've got it all bench tested and I know it all works. I'm also going to cover a few little odd jobs that I've done, but electronics and glazing is the main thing. So, without any further ado, let's just crack on. So, to do the UV resin, I got myself a syringe because I was really racking my brains to think of another way of being accurate enough with this stuff. So I got a syringe and a selection of sort of fine pointed needles off eBay. And I used that just to accurately apply the resin into the countersunk area behind the portholes. And because it was nice and viscous, it would stay there. So you could do 5 or 6 portholes at a time and then solidify them using your UV light, and it ended up working quite well. The other nice thing about this is that because I was inserting the resin from the back, it means that the glass, or the glass effect, isn't quite flush with the hull on the outside. There's a slight indentation, which of course was what actually happened on the Titanic's hull. The portholes weren't absolutely flush with the side of the ship. They were slightly recessed, and that's exactly what I've ended up with. So I'm really happy with how this has turned out, actually.
So on the larger portholes, I'm wanting to use the photo etch set to give the impression of the 19-inch by 24-inch portholes. So what I've done is I have put a layer of UV resin in from the back, from inside the hull, and cured it. And what this leaves you with, because of the surface tension, it leaves you with a slight indentation in the porthole. And that then allows you to insert the photo etch into the hole and add just a very, very, very small amount of additional UV resin and then cure it in place.
once I'd finished all the holes, I just dumped the boat outside for a bit in the sun. UV resin is, it's activated by ultraviolet light, so I've used the torch for the main bit, but just to guarantee everything's nice and hardened up, I just whacked it in the sun for a few hours and that did the rest. So, with the hull all portholed up, on now to the electronics, and the first little job I had to do was to work out where in the boat I was going to be able to mount it. And the idea I've come up with is I made some sort of pretty rough tables which are able to sort of sit over the top of the batteries. These are made out of pretty cheapy pine wood, and if I'm honest, I didn't put a huge amount of effort into them. As long as they're sturdy, that's all that really matters with them. These allow me to mount all my components quite securely in place.
So this is where we're at now. I've got my positive battery terminal here, so your 3 incomers from the batteries will be there, and my negative terminal there. I've got my propulsion fuse leading to my speed controller, and then my positive motor terminal, so you'll have the 3 outputs to the motors here, and the negative motor terminal here. Receivers and other fuses for the smoke and lighting will go here. For joining everything up, where wires aren't included in products, so obviously I've used the speed controller wires here, but for joining everything else up, I've got 2 types of wiring from RS. This is 16 AWG, I think. Yellow and blue. The reason I chose yellow and blue is because it conforms with the yellow and blue positive and negative that's on the speed controller. It doesn't properly adhere to wiring regs, but I don't really think I need to follow IET wiring regs for the electronics inside a model boat.
Right, so here is my electronics. It's pretty basic really, pretty simple. I've put most of the focus on it into fusing and stuff like that to make sure that we're not going to blow anything up particularly. So here I've got my 3 incomers from the 3 batteries. This, at the minute, it's wired just to go straightly to the main distribution bus, but what I'm going to do in the future is run it via this. This is a wireless activated relay, so essentially you get a fob like this and you can tap to unlock and tap to lock, and that will engage or disengage the contacts of the relay. So what this will mean is that when you get to the boating lake, instead of having to sort of take the whole boat apart, plug your batteries in, make sure everything's up and working and connected correctly, you can set it all up at home instead, in the warm, in the dry, and then just once you get to the lake, you can unlock the boat, test the radio control, make sure everything's still working, and plonk it straight in the water. And the reason I've gone for this is because I tend to find most of the accidents I have with stuff like this is at the boating lake when I'm taking the boat out of the water or putting it in at the start. There's always something, it's like, I don't know, like
if you've been sailing a boat and then it starts raining and you're in a bit of a rush to get everything back in the car, and that's when your mistakes happen. So having something like this, which removes the need to do any kind of disassembly of the boat by the water's edge, is really, really useful, I think. I'm going to fuse that. At the minute there's a 10 amp fuse in there, but it's not going to be 10 amps in the final thing. I'm going to fuse that at 1 amp, and I'm going to run it off a separate power supply because I'm a little bit worried about spikes and stuff produced by the motors, which there's there's very sophisticated electronics and things like the crystalline stuff, so I don't particularly want to run the risk of the board getting fried by back EMF and stuff coming from the motors. Anyway, so moving on from the sort of activation circuit, we've now got the main fuse for all of the equipment on the boat, and that is 15 amps. Then we come to the main distribution board. At this point, we take away the positive supplies for the motor control, and then I've got a fuse each for the smoke generator and the lighting circuit. Smoke generator is going to get fused at 4 amps, and the lighting circuit's probably going to be about 2 amps. Fuse the motor at 10 amps, and the actual speed controller itself is it's a Viper marine speed controller, and that's a 15 amp rated. So this fuse will do enough to protect it for certain. I've also then got my radio transmitter, my radio receiver, which will sit here, and obviously that'll control all the other functions on the boat. For the smoke and the lighting, I've bought some radio controlled circuit boards, I guess, so they can be activated by using any of these switches. You know, it's just a digital channel input, so that I can turn on the smoke and lighting remotely. And then the final part is these two boards here. There's 3 terminals, because obviously 3 motors. At the minute I've only wired one up, just as a bit of a proof of concept. But there's 3 terminals, so these will connect to all the positives of the motors and then all the negatives of the motors. The central propeller, I'm going to put a diode in so it doesn't go in reverse. Titanic's central propeller was not reversible. The 2 wing propellers were driven by reciprocating steam engines, and the central propeller was driven by the exhaust of those steam engines passing through a low pressure turbine. And obviously it's not impossible, but it's relatively difficult to reverse a turbine, so that central propeller was not reversible. So I'm going to do exactly the same thing, and I'm going to achieve that by putting a diode in the way. So just to give a bit of an example, I've only got 1 battery wired in at the minute, but all my batteries go in parallel, so it doesn't really make any odds. There we go. I don't know if you can see it actually rotating, but there's the motor rotating from the speed controller. Nice and easy. These motors are geared at a 1:6 ratio, and they're pretty damn powerful actually. I can't really, I'm struggling to stop the motor rotating with my fingers, and that's a good sign, because the power is useful if the boat gets stuck in some pondweed or something. What would normally happen is, if the motor gets stuck in pondweed and then can't rotate, a DC motor's maximum current draw happens when it's stalled. And that is when you run the risk of blowing fuses and stuff. So by having more power, you're reducing the chances that the propellers are going to get jammed up by weed. And obviously having 3 propellers rather sort of stacks the odds in your favour. So there you are, there's the electronics. So just to give you a proof of concept on what I'm working on, I'll have my motors here, like so, and directly behind them the distribution board, or I guess you could call it a motherboard almost, with underneath a battery. Next you have room for the smoke generator here, and then 2 additional batteries depending on the weight of the model and the balance of the model in the water. So quite compact in the end, bearing in mind I'm also going to have to fit the lights around this, but I'm confident it will work. So I'm starting to think about mounting my motors now, and what I've decided to do is to put them on a bed of vulcanised rubber. So this is the same sort of rubber you get in your tyres on a car. And what it'll do is it'll just remove some of the higher frequency noises. It's essentially like putting the motors on a bit of a suspension. The other reason for needing this is that if you look at the gearbox it actually sits slightly below the mounting on the motor. So if you put it on a flat surface, the gearbox would foul on the floor. So you need a sort of pedestal to put the motor on to raise it up high enough. So these are the motors that I've chosen for the build. They are nominally 12 volts, but they go from 4.5 up to 15. And they've got a gearbox with a 6:1 ratio. Don't be fooled by them. They look quite big in my hand, and certainly when I ordered them, I did sort of think, crikey, 3 of these in a boat this size might be a bit overpowered, but in the reality, the gearbox, the red bit, makes up the vast majority of the motor. If you look at just the motor itself, it's actually a fairly low size motor.
So in this image here, I'm just doing a test fit to cut my battery leads to length. On this build, I am using crimped connections wherever possible. Sadly, it's not possible on the motor terminals because they're designed to be soldered, but wherever possible I'm using crimps because I much prefer them. I think that they are significantly stronger than a soldered joint. They're much better at vibration resistance and they're much longer lasting. I just think generally they are better. Like I say, in some places it's not possible, but wherever I can, I'm going to crimp things. So that's all the electronics. Hopefully in the next episode I'll be able to show you it actually in the boat, hopefully with the lighting system attached, but we'll see how we go on that one. It's nice to actually have it, fully designed and in concept at least working. If anyone's interested, let me know in the comments, and I can, if you want, make a circuit diagram and put it in the next episode, just if people are interested. So in other news, I have developed a automatic oiling system for the propeller shafts on the boat. I've done this by drilling and tapping each of the prop shafts, and I've then inserted a model steam engine grease cup into each of them, and I've locked those in place with Loctite. When I installed the cups, I used a needle file to create a slight sort of concave shape so that there's no chance they were going to foul on the propellers or anything like that. I think if I had my time again, I would braze these onto the prop shafts instead of using Loctite, because I think that's a much more secure way of doing things. Sadly, this was an idea that I'd had after I bonded the propeller shafts into the hull, so brazing wasn't really an option for me anymore, but if I did it again, I would certainly braze them. For the oil reservoir, I used one of those little sort of acrylic boxes you get for semi-precious stones and stuff, and I just drilled a hole in there and chopped off the end of a pneumatic air fixing and cemented that in place. I then got a 4-way air fixing and used that along with silicone tubing to route the oil into each of the shafts from the reservoir. Pretty simple, pretty basic, not a lot of expense or real skill required to do this, but it's one of those things that I think is quite important, because oil in the prop shafts, it does a lot of things. Obviously, these are mechanical parts, they require lubrication, it's important for that. It also helps with things like keeping the prop shafts watertight. So it's a pretty useful job, I think. So that is all the progress that I've made in the last couple of weeks. So I'll bring the video to a close there. Thank you very much for watching. I hope you found it useful and maybe got some ideas from it. If you did enjoy it, please give us a like and subscribe, and I'll see you in the next one. Bye for now.